and learn how to do synthetic division, which is a shortcut. And then we're going to learn what we can do with long division and polynomials and how that can help us. So long division, we have x minus 2 into x squared minus 6x plus 9. I would ask myself, x times what gives me x squared? And you would say x. And x times x minus 2 gives me x squared minus 2x. The place that people mess this up is right here. What do I need to make sure that I do?
Add.
Change the sign of both to subtract them both, which gives me a negative 4x plus 9. And I ask myself, x times what gives me negative 4x? Negative 4. Negative 4 times x minus 2 is negative 4x plus 8. Sign change. So I'm subtracting, but I just went ahead and changed the signs and added. So essentially I did negative 6 minus negative 2, which is negative 6 plus 2. That's why I always do that. Change there. Sure.
Well, because it's really possible.
The negative 6x. Now I haven't changed the signs yet. Is that what you're talking about?
It's minus
negative 4.
Yeah, but you already have negative.
I know. These better be the same thing. If they're not identical, I did something wrong. Because if I subtract the same thing from itself, no matter negative or positive,
So you're going to add it here.
So now I'm going to subtract, which means that becomes a plus, and that becomes a minus. So I always make 2 marks, change both signs. Those subtract to give me 0, this subtracts to give me 1. So I get x minus 4 remainder 1. Now, what that did for us is I now know that x squared minus 6x plus 9 divided by x minus 2 is equal to x minus 4 plus 1 over x minus 2 if I wanted to write it that way. There's a couple of different ways we can write it, and I'll show you that later. Today our focus is going to be trying to factor polynomials using division. Before we do that, I want to learn a shortcut, and that is synthetic division. It is just a shortcut. It's not a replacement of long division, but man, it's going to make your life easier. Now, the person who came up with synthetic division knew that you were tempted to forget to change the signs, right? So they fixed that for you in synthetic division. How you start synthetic division is you put a little box here, and you put this 2 with the sign change. So instead of negative 2, you put positive 2 in that box. Essentially, synthetic division is going to take out variables, which is what make our brain hurt, and make it easier on us. Beside that, we're going to put the coefficients of the dividend of this. So what's the coefficient of x squared? What's the coefficient of negative 6x? What's the coefficient of 9? Now, one of the things you'll have to pay attention to, this one didn't have that problem, one of the things you'll have to pay attention to is if there are any gaps. If you skipped the x term, you'd have to put a 0 placeholder in there, because you're getting rid of all the variables. You need to know what place it was, and we'll talk about that in just a second. So the algorithm for synthetic division is you take this first coefficient and add it down, straight down. So start by add down. Then you're going to multiply this 2 by this 1 and put it here. You should have done it too. I don't know.
I remember liking it.
So add down, then multiply. So you multiply the 2 and 1, you put it there. And then you repeat. Add down, -6 plus 2.
Is that right?
It's okay. And then we multiply the -2, or the 2 times the -4. And then you add down. The last number, I'm going to put it in a box. Because what is that last number? The remainder.
The last number always will be the remainder.
Uh-huh. What did the 1 and the -4 give us?
X coefficient.
The coefficient of the quotient. Now, since I'm dividing out an x, would you agree that this quotient would be 1 degree less than what I started with?
Yeah.
So this is x minus 4.
Can you use the help?
Yes. Okay, so this is the shortcut to long division.
I love
So there won't be any problems like
Some tips. Synthetic division is a shortcut that cannot be used on everything. So you need to know when it can be used. To use synthetic division, the divisor has to be linear, like x minus 2. It can't be x squared plus 5, right? Even 5x minus 2 is a little bit more difficult. I'm not saying that can't be done with synthetic, but it takes a little more work. If you don't have a divisor of just a plain x minus 2, my recommendation would be to go back to long division. But for all the ones, and most of them will be, just normal linear terms, we're going to just divide them out using synthetic. It will save you time on almost all of them right now.
Come on, Matt. Pay attention.
Okay, number 2. Anytime there is a term missing, so in standard form, we start with the highest degree, 4, 3, 2, 1, none, right? Anytime there's an x missing, you have to put a 0 for a placeholder there. And number 3, don't forget to change the sign of the constant in the linear factor. Again, the reason we do that is that's changing that second sign in the long division. The time that we have to change the sign, that we always forget to do that, it's doing that for us. So, you have to use the opposite sign of constant in the linear factor. Any questions about that? Yes. No problem. Yes. Just it's that buffer in the hallway. Okay, next slide. So we're going to practice. And this says to write the answer in Q of x plus R of x divided by D of x. There are 2 forms. We'll write these in sometimes and I'll show you both. So, what goes in the box? 3 goes in the box.
3. So if it had been a plus 3 with -3 on the
That's right. I always change that sign. Am I skipping any x's? No, so I just put the coefficients down.
-3, -3,
I thought you were supposed to put negative.
Change the sign. It is -3.
It's the x minus 3, not the 2. Yeah.
Okay. Add down. Always first you add down. Multiply. Add down. Multiply. Add down. Multiply.
Add down to the top.
Add down and put that last one. Any questions about?
I got that in front. Because
Now,
big number in the remainder.
what is the quotient? Because 3, 7, and 24 don't tell me very much.
3x squared.
Why is it x squared?
They want minus 6.
Good, it's one less than what I started with, because I divided an x out. If it was an x cubed, if I divide an x out, it's going to become x squared. 3x squared plus 7x plus 24. Now, normally I'd put R68. It told me to put 68 over the divisor, which is x minus 3. The divisor. And the only reason you'd write it that is because it told me to. Otherwise, you could just do R. Yeah, no. Let me show you why this is what it is. If I were to divide 3 into 28, right? What is 3 into 28?
That's not right.
You go to the
Hang on. It's a Monday.
You right? What that is saying is that this equals the quotient plus the remainder over the divisor. Would you agree that 28 divided by 3 is 9 plus a third?
Yes.
So that's just a way to write it.
You could never have a negative
Yeah, you can. Not in this, you can't. Not in numbers, you can't. But in polynomials.
So why did you get 9 plus 1/3?
Now, would you agree that 28 over 3 equals 9 and a third?
So the third came from 1 divided by the 3.
So I was just showing you how that's the same in numbers. What in the world this problem was making you do. Question. Is x minus 3 a factor of this big polynomial? How do you know? Because it has a remainder, right? A factor would go in evenly. So, no, because we had a remainder of something other than 0. You just quoted the factor theorem. If something is a factor, then the remainder, when you divide that out, would be 0. That's what we're going to be using today, momentarily. Okay. Factor the polynomial given the 0 x minus 6, or given the factor x minus 6. So I know x minus 6 is a factor.
Is that 21?
Where there's got a 21 in there.
Oh my gosh.
Oh, I see. Yeah, number 2.
Sorry.
Do what?
240.
It is 240.
240.
So it says factor the polynomial given a factor x minus 6.
I just do what we've been doing.
So we're going to divide x minus 6 out. Okay. Before I start synthetic division, ask yourself, are there any x's missing? No? If there are, what do? Put a 0 in. Okay? Notice I put a positive 6 in the box because it's x minus 6. Good so far? Uh, 88?
78.
Yeah.
Is x minus 6 a factor?
Yes.
It better be. It told me it was when I said given a factor. But if I hadn't gotten 0, I would know that I did something wrong because it told me x minus 6 was a factor. So what that means is that polynomial, so this is the other way to rewrite, equals this big polynomial that we had at the beginning equals x minus 6 times what?
Is it minus 2 or not?
Say that again. Now this, oh yeah. So, x cubed plus 7x squared minus 38x minus 240 is equal to x minus 6 times x squared plus 13x plus 40. Would you ever have been able to get that factor without division? So we've learned a new skill, a new factoring technique. If we can find 1, 0, we can divide it out to factor. And then I can keep factoring, can't I? Just said factor. How'd you get that? Stop talking. Good. Factors of 40 that add to give you 13 are 8 and 5. So I have fully factored this polynomial. Now, Remington said, do we need to find the zeros? This question just said factor, but could we?
Yes.
We could. We know it's 6, negative 8, negative 5. So we've gotten to where we could plot the zeros, do some things that we couldn't do before. So that's the new skill today. Okay, this one's a hard one. Worst kind that there are. Why is it bad?
Multiplicity of 2 on the end of that.
Now, before I start, this question is different. The last one gave me a factor, x minus 6, right? This one I have a 0.
So it's just x plus 3 times x plus 3.
Good. Wouldn't this be x plus 3? Well, I don't have to think about that. Good. So if you're given a 0, put the 0 in the box. In fact, that's what that slide said at the beginning. Put the 0 of the divisor in the box. So if you're given a 0, you don't change the sign. So that's weird. Be careful about that. Star that in your notes. If you're given a factor, you change the sign. If you're given a 0, then the factor is x plus 3, and the sign is already changed. So be careful about that. Star that in your notes. Negative 3 goes in the box.
Wait, it said given a factor, don't just sign given a 0.
No.
So are we going to divide this the second time?
Yeah. This one is bad because it's a 4th degree. To get it down to something I can factor, what do I need to get it down to?
X squared.
Quadratic. So how many times am I going to have to divide? 2 times.
Wait.
Okay, ready?
Hang on 1 second.
Okay.
Yeah.
Hang on.
I'm just trying to So after we apply this, what I like again.
Yeah.
Also, when it has multiple, let's say 3, we do it 3 times.
If it did, I don't think you'll see any like that, but if it did.
I mean, if it did.
If it did. Add down. Multiply. Add down. Multiply. Add down. Multiply. Add down. Multiply. If I don't get 72 there, I did something wrong, right? Because it told me it was a 0. So if it's a 0, it better go in evenly. So if you had accidentally done +3, it might not have worked. It probably wouldn't have worked. So you have to go, okay, what did I do wrong? Okay, so if I were to write this as a polynomial, wouldn't it be x cubed plus 3x squared minus 8x minus 24? Which I still can't factor.
So you should have.
Do it again.
Oh my god. Ever hear you talk?
It is. It's pretty cheap.
Whatever you get down to, do that.
Divide it out again. If it gave you 2 different zeros, you just divide one out, then the other one out. This one, it gave us the same 0 twice. But you just divide both zeros out. This one gave us 2 zeros. They just happen to be the same number. Yeah, you won't, but you would. Again, I get 0. I hope so. Right? So this now, our polynomial up there, I'm going to call it f of x, is x plus 3 times x plus 3. Why twice? You could do x plus 3 parentheses squared.
Yeah.
Any questions so far? Since it's not a perfect square, you can't. Now if it were a 4 or a 16. Now let's go back and read the question. It said factor. Did I do that? I'm done. I can't factor x squared minus 8 anymore. Now what if it said find the zeros? Okay, it didn't ask this. But if it said find the zeros, they would be -3, and then we would have to do x squared minus 8 equals 0. Which is 2 radical 2. So if it did say find the zeros, we could now. It is that multiplicity here would be 2. Any questions about that? Again, that was a tough one. That is tough as they get. Hey, for the polynomial, a 0 is given. Find all of the others. Try this.
which one is it?
I didn't say worksheet. I can't read that far. See, you well, I didn't look at it. No. It's okay. You can take this one back.
Hold on, don't start working any of it yet. Just pass it out.
All right. Let's work this one. What goes in the box? Why is it 4? If 4 is a 0, what factor did it come from? Right? Everyone understand that difference? Okay. 1, -6, 13, and -20. Notice there are no gaps, right? Cube, square, 1, none. You will have some that occasionally have gaps. Add down. Stay with me. Stay with me. I'll tell you about it in a minute. Stay with me. Put them up. I'll go to receipts in a minute. Okay, any questions so far? So our function is x minus 4 times x squared minus 2x plus 5, right? Now, does that factor?
Yes.
How do you find the other zeros if it doesn't factor? Maybe. Maybe they're just decimals.
Oh, yeah.
Quadratic formula, right? Now, I don't mind. Do you have a way to do that quickly?
Program.
Quad 3? Right? Type that in quad 3. You probably should come get it that way. Or if it took you longer to do quad 3 than it took me to do the quadratic formula, you could just do the quadratic formula.
Is quad 3 in the
Program. Got it. So these zeros are 4 and 1 plus or minus 2i. 1 plus 2i and 1 minus 2i.
You're just putting the x requires to subscribe to the quadratic.
Right. Because it is a quadratic equation. So if I want to find its zeros, I have to. Or if it doesn't. It would be nice if it factored. Okay, your homework.
What?
On 6A worksheet, give them out. You have them. A. There's an A and there's a B. 1 through 4 all on 6A. And the back, you do the evens. On both of them, you do the evens on the back and the whole front. Essentially is what that says. And the evens on the back and the whole front. You don't know. That way, it's mistake. Okay, so on the 6.4a, 1 through 4, you need to do synthetic division and decide if it's a factor or not. On 10 through 18 on the back, you you just use synthetic division to divide. I'm fine with you just writing the quotient remainder this. That's fine. On the quotient, make sure you put the x's back in. Don't leave the numbers as the answer. Does that make sense? This page is just synthetic division, just to practice synthetic division. This one is where we start factoring the polynomial as far as it factors. This one's the upper of the two. It's not too terrible.
Teachers and students, can I have your attention, please? Noon detention for both A and B lunch today has been canceled. The noon detention for A and B lunch today has been canceled.
I do have a hint for you. On number 5 on this page. B. On number 5 on B. Hint to you. 2x plus 1, you'd have to do long division to divide that out, wouldn't you? That's a cubic. Do I need to divide it twice? Divide out the x minus 4 and then factor. You don't know that one of the factors is 2x minus 1. You don't know. So, hint, I would do the x minus 4 first. Do what? Yeah. On number 4, on this front page, that's the one hard one on this whole worksheet. You have to do it twice, don't you? What makes it one that I have to do twice? X to the 4th, right? That's what lets me know I'm going to have to divide out the x minus 2, and then I'm going to have to divide out the x plus 3. Get started. You still have a little bit of time. Okay. You can, but if you divide out the x minus 4, go for it. Yeah, you can divide it, but you have to do long.
I see it's getting a lot.
Right, it doesn't get it all the way down to the quadratic, so I have to keep dividing. So if you get it to a quadratic, you can do that.